In this video, we're going to be discussing the concept of percent composition, which is very simply put, what percentage an element is by mass in a given compound. Again, you're going to need a periodic table, a calculator, you're going to need something to write on, something to write with. Once you have all those things ready, let's go. All right, so as I just said, we talk about the percent by mass of each element in a compound as percent composition. So the way that we're going to find this is we're going to take the total mass of the element in our sample, divide it by the mass of the sample, and multiply it by 100%. So this means, for example, if I said a 5-gram sample of a compound had 1 gram of hydrogen, well, 1 gram of hydrogen divided by 5 grams of the sample is 20%. Right, that math is very straightforward. Now, sometimes I won't give you masses like that. I'll give you just the chemical formula and ask you what the percent composition is for that. In this case, the molar mass is going to serve as the mass of your sample, and the mass of the element will be just the portion of it that you added up for that one element, right? So if I were doing water, I would take the mass of 2 hydrogens and divide that by the molar mass of water. So let's try an example of this. We'll try to figure out the percent composition of barium and chlorine in the compound barium chloride. First thing we need to do is know how much of each thing we have. We have 1 barium atom, or 1 mole of barium, I should say, which has a mass of 137.33 grams. We have 2 moles of chlorine. Each mole of chlorine has a mass of 35.45, so 2 of them is going to give us 70.9. To find the molar mass, I just add those 2 numbers up. I get 208.23, and that will be the same molar mass for both elements. From here, I just do my division. Percentage barium, 137.33 over 208.23, gives us 65.95%. And for chlorine, 70.9 over 208.23 gives us a percentage of 34.05. Again, notice these 2 numbers do add up to 100. They don't always have to add up to exactly 100 on the dot. If you're within 1 in the last decimal column, that's kind of okay because we'll assume that there may be some experimental error involved in the measurement. But as long as you're close enough, that's good. So that's percent composition. In our next video, what we're going to do is we're going to use these percent compositions to work backwards to make the formula for our compound.